We can use that. Okay. And we will elaborate both of them, use of both of them. So see, first we start with a parallelogram law of vector addition. So for the parallelogram law of vector addition, just we observe that in the triangle law of vector addition, or to apply the triangle law of vector addition, we must have the vectors oriented in order. In order means they should be oriented head to head, head, tail, head, tail. In this way, the vector should be oriented, and the closing side of the triangle represents the resultant vector. Here in the parallelogram law of vectors, we state how to find out the resultant here. Okay. So now here the statement says that if the if two vectors if two vectors can be represented in magnitude and direction, two vectors can be represented in magnitude and direction by the two sides of a parallelogram, by the two sides of a parallelogram, then the resultant side, then the third side, provides the resultant. Then the third side provides the resultant. Oh, sorry, not the third side. It's not the third side here. Then the diagonal. There is no third side here. It's the diagonal. So we'll see. Then the diagonal represents the resultant in magnitude and direction both. So let's see how this works, and we will see that it is also an adoption of we will see that it is also an adoption of the triangle law only, but stated in some other way. It's the same as we studied the triangle law, but a different way of saying it. So in the parallelogram, to apply the parallelogram law of vector addition, the two vectors should be represented co-initially, something like this. They should be represented co-initially by the two sides of a parallelogram. So here we have two sides of the parallelogram, and the two sides of the parallelogram, they are being representing two vectors. Here we have the vector A, here we have vector A, and let's say this be vector B. Now, the angle between vector A and B, let the angle be theta. Let the two vectors A and B act at an angle theta. Remember, for the triangle law of vector addition, we had taken the vectors something like this. We had taken the vectors like this in order. For the triangle law, we had taken the vectors in order like this. And here, the third side or the closing side represented, here the closing side represented the resultant taken in opposite order. So here this was the third side, it represented the resultant in closing order. Okay, like this. So here if I take some vector A and let's say vector B, so this would be the resultant. Also here, the angle between the two vectors was not this. This was this vector. This angle was the angle between the two vectors. That's the angle theta. You can move the angle vector parallel to itself and you will observe that this is the angle. So the vectors A and B, they are making angle theta with each other. Now if I draw another, so to complete a parallelogram, now I can complete a parallelogram by drawing two lines. I can draw two lines, a line parallel to A. So I will draw a line parallel and equal to A like this. A second line I will draw parallel and equal to B. So here. Now, as you can see, we have completed a parallelogram. So we have drawn a vector parallel to A. We have drawn a vector parallel to B. So in this way, we have completed a parallelogram. Now, in the parallelogram law of vector addition, the resultant is represented by the diagonal. So the diagonal of A and B, the diagonal of this parallelogram, it is going to be somehow this one. We can get this side as the diagonal. So here, as I can see, this side will be the resultant R, both taken in magnitude and direction. Here also, if you take the angle beta, so I take the angle beta, and for this angle beta, for the angle beta, we have taken, we can find out the trigonometric ratio tan beta, and hence tan beta would be equal to b sine theta over a plus b cos theta. So this was the formula we did yesterday to find out the angle beta which the resultant vector makes with one of the vectors. Okay, with the vector A. So here the beta is the angle found with vector A. So we get tan beta as this. Also we got the resultant, magnitude of the resultant can be obtained by the formula under root of a squared plus b squared plus c squared, sorry, a squared plus b squared plus 2ab cos theta. So the same way, as we used in the triangle law, the same thing holds here also. Mathematically, your tan beta would be given by the same formula, b sine theta over a plus b cos theta, the direction, and the magnitude of the resultant vector would be given by under root of a square plus b square plus 2ab cos theta. Even when you are using the parallelogram law of vector addition, so then also you will use these formulas only. Okay, the resultant will remain still the same. You can see the parallelogram is just an interpretation of, it's an interpretation of a triangle law of vector addition only in another way. How I see, as you can see, if I make here some, let me rename the sites as P, Q, R, and S. These are the vertices P, Q, R, S. So if I observe here in triangle PQR, if I observe the triangle PQR, can I say that in the triangle PQR, a triangle law of vector addition has been applied? Because we observe that vector A and vector B, they are taken in order. You can see a line has been taken which is equal to A. So B is equal to A, and the direction of B is also the same as the direction of here PC, PS. The direction of PS and QR, it's the same. Their magnitudes are also same. So I can expect here that this is nothing but the triangle law where I observe the PQ vector and QR vector arranged in order. They are arranged in order. Okay. So Dhanunjay and Jaswant, have you understood this point?
Yeah, sir.
Yes, sir.
Okay. So just only difference is that if you are using the parallelogram law of vector addition, so the vectors which you are taking, they should be co-initial. Like here, the vectors A and B, they are starting from the common point P. Okay, so then only then you can complete the parallelogram. Okay. But in the triangle law, the vectors have to be oriented, or they have to be arranged in order of a triangle, or in the form of a triangle. Okay. Now let us see another interpretation of the triangle law. Okay. I hope you have understood about the parallelogram law and the triangle law of vector addition. Okay. So Shreya, as you can see, parallelogram law of vector addition, it states if two vectors can be represented in magnitude and direction by the two sides of a parallelogram, then the diagonal represents the resultant in magnitude and direction. So here we have taken the vectors A and B, which are co-initial. And now if you draw a diagonal, okay, so the diagonal represents the resultant taken in order.
Yes.
Now, uh, I told that this is same the interpretation of triangle law only. Okay, let us try to apply the triangle law to a polygon law. Okay, so suppose I want to add three vectors. So how can I add those three vectors? So if you have to add three vectors, for that we have a polygon law, or you can use your triangle law multiple times. Okay. Triangle law multiple times means suppose if you have three vectors, you have to have vector A plus vector B plus vector C. You want to add them. So what you do, you first add A and B using any of the law. Either you use the triangle law or parallelogram law, whatever law you use. So use these two laws, find the resultant of this. And whatever resultant you get from here, add the resultant to the vector C. And this will be your final resultant. This will be the final resultant vector that we get. For example, for an example, let us consider here the vectors A, here a vector B, and let's consider here another vector C. So they are arranged anywhere randomly. I have taken any random orientation. You can take any. Whatever you want to take, you can take any. Okay. So here, let the vectors be A vector, B vector, and C vector. So my first step, first I will be adding A and B, and I can use any of the law. I can use either the triangle law or the parallelogram. Okay. So which law should I try? We have just now learned about the parallelogram law. So can we do parallelogram? Yes. So for that, I move this A near B and complete the parallelogram. So in this way, you can see just by moving it parallel, I have obtained I have obtained a parallelogram. Here I can now complete a parallelogram. This is my vector A, this is B. Here this is the angle theta between them. And now if I complete a triangle, complete a parallelogram. So for that, I need to draw a line parallel to B, a line parallel and equal to B, and a line parallel and equal to A also. So both this way I will be drawing.
Yes.
And the two lines, they meet at this point. Now the resultant vector will be given by the diagonal. So we have to draw the diagonal which will represent the resultant here. So this one is my resultant. Using this I have got using, this is my resultant R1. Okay. Remember, this is the resultant R1. Now, this one I have got using the parallelogram law of vector addition. I have got R1. Now I can find I have to add the next vector C to the resultant vector R. Okay. So for that, let's move it parallel. Let's move it parallel to C. So you have this C. Okay. So let's move here C and take this R. So I'm just moving them parallel. Okay. I'm not changing their direction. So see, here I have moved them. And this is the angle which I obtained. This is the new angle which is between C vector. This was your vector C and this is your resultant vector R1. Now they can be added up. These two vectors, they can be added. So here I have R1. Let's replace C wherever it was. Okay, so this was C, which is parallel to this. Now, the resultant between them can be completed by completing a parallelogram just simply. So I think if you want to get the resultant, so you will complete a parallelogram. So such a parallelogram would seem something like this. So from here, I need to draw a parallel line to this, like this, and here I think it's okay. And then the resultant would be somewhere here. This is the resultant. Are you getting the resultant? How we obtain the final resultant? By completing the parallelogram, we have obtained now the diagonal, and this is the new diagonal, and hence it is the new result.
Yes, sir.
This is the new resultant R3. Jaswant, Dhanunjay, any doubts?
No, sir. That's good.
Okay. Now for simplicity, okay. So see, as you can see, it becomes a lot of complicated as you are adding more and more vectors. Okay. So for the improvement on this, we made a polygon law. Okay. So let's see how to make a polygon law. Polygon law means if any number of vectors are represented by the sides of a polygon taken in order, then the closing side would represent the resultant taken in opposite order. So it's here.
Yes.
I can give the same using a polygon law of vector addition. Okay. So using the polygon law of vector addition, if a number of vectors, okay, have you all attempted the test?
Not yet, sir.
Then do attempt the
Not yet,
test.
sir. I'm going to do after this, sir.
Yeah, after this, do attempt the test. Okay. Your physics test will be live up to 10 p.m. Okay. So do attempt the test. If a number, see, it will just give you a little bit of practice, whatever you have studied. If a number of vectors are represented by the sides of a polygon, then the closing side. So now it becomes very simple. Then the closing side represents the resultant taken in order, taken in opposite order. So its order has to be opposite. Okay. So see what it means. If you have, suppose in the previous one, I had to add three vectors, right? So if you want to add three vectors, so represent the three vectors by the sides of a polygon. So this was, if I represent them like this, so I represent it here by the three sides of a polygon, then the resultant would be represented by the third or the closing side. And the third by the closing side, so the closing side would be taken in opposite order here. So this is the closing side taken in opposite order, and now it represents the resultant. So it holds for any polygon. Any polygon means even if there are four vectors, five vectors, so you can get the result. Any doubts?
No,
To
sir.
No, sir.
understand this, how it comes, let's see very simply. You have the vectors A, vector B, and vector C. You have to add these vectors, right? So if I'm adding just vector A and B, so the resultant would be the closing side of AB. Yes. So this side would be the closing side. I can just take this side to be the resultant. This would be the resultant of A and B. Yes, just one. Is it correct? R1 should be the resultant of A and B. It should be A plus B by the triangle law of vector addition. See, by the triangle
Yeah,
law of
it
vector,
is.
it is. So by the triangle law of vector addition, I am getting R1 as the resultant. Now, if you see above that you also have, you are forming another triangle. So if you see R1 plus C, so R1 plus vector C, are R1 and C, they are in order. Can I say R1 and C are in order?
Yes, sir, they are, sir.
Yes. And if I complete the triangle, so the closing side taken in opposite order. So again in this part of the triangle, in this triangle also I am applying the triangle law and finally getting the resultant equal to R. So here I am also proving the polygon law of vector addition. Again using the
Yes.
triangle law only. Okay. So now can you try out a small question? Okay. Let's see a small question. This is from the triangle of vector addition only. Let's see if you can do this. So here, if vectors A, B, C, and C are represented by the three sides of a triangle taken in order. Find the sum of all three vectors. So I hope you have got the question. What the question says? You are given three vectors: vector A, vector B, and vector C. Okay. The three vectors, vector A, B, and C, they are represented by the three sides of a triangle taken in order, and you have to find what would be their sum. So, if I simply complete a triangle anyhow, so I have taken a triangle, and these are the three vectors taken in order. So I'll make here in order. Uh, this is correct. Vectors are in order. A vector,
Yes,
B
sir.
vector, and C vector. They are taken in order. So my target is I have to find vector A plus vector B and plus vector C. So all these three have to be added together to give you the final result. This is what is you are supposed to find out. So can anyone tell me the answer? What would be the answer? Any guesses? Okay, so I'm giving you one hint. You can try out with this hint. Just hello. आ गए नीचे ठीक है ए ए भूमिका सुनो Okay, so I told you I'll be giving you a hint. Okay. So anyone tried out this? Okay. So the hint is here that a vector, if you are taking a vector A like this, suppose this is given to you as vector A. You have this vector A. Okay. So if I am saying you negative A, if I say minus A or negative A vector, so negative A vector means the same vector A taken in opposite direction. So the same vector A taken in opposite direction, that is magnitude should be same and the direction should be just opposite. So this would represent minus A. It would represent negative A. So now you can try out. You can try to get. Pick up the Come to the screen. Pick up the आवे रहेगा वो। Yes, any tries? Okay, let's do this. So, okay, find out the resultant of A and B. Shreyasi, find out the resultant of A and B. If I try to find out the resultant of the vectors A and B, so I try to construct, represent
It will
them with the,
be negative C, we can say.
yeah, it will be negative C,
Yeah,
right?
yes, sir.
Oh, yes. So see, I can get from this figure, I can get that A plus B would be equal to negative C,
Yes,
right?
sir.
So if you transpose this negative to C to the other side, or if even if you replace this A plus B with minus C, so what should be the sum A plus B plus C equal to?
0.
0.
Oh,
Getting? So the answer to this question is 0. You have the answer as 0. This one,
yes, sir.
Dhanunjay, have you understood this question?
Yeah, sir.
Yes.
Yes, sir.
Yes. So in the similar way, if I give you suppose four vectors here. So suppose I give you four vectors. This is vector A, B, C. Okay. So you get the three vectors, vector A, vector B, and vector C. If I want to find out their resultant, okay. So what should be the resultant there? Another vector. Let's say another vector I have D. So what would be the resultant vector? Hmm. What should be the resultant vector? What did be the closing side of this pentagon? Yes, I just need to
From,
close the pentagon and it should be from A here to this.
huh,
So this
yes,
should be the resultant. Okay.
yes,
And it can be proved using the triangle law. It can be verified, it can be proved using the triangle law that if you add A and B, you will be getting here one resultant C. So this is the another resultant, let's say P. Then if you add this P, this is the resultant P. If you add P and C, you will get the resultant here Q. So this is the resultant Q. If you add Q and D, you will get the resultant R. Okay. So today we have understood, or we have done all the triangle law of vector addition and parallelogram law of vector addition. Okay. So now let's try to do a small question depending on the parallelogram law of vector addition.
Okay.
So where in the diagram given, right here, in the diagram given, find the weight of if the tension in the rope if the tension in the rope is given, so this diagram is something like this. Okay, we'll do this question later. Okay, so currently I have some other class also, so we'll do this question later. And I hope you have understood about the parallelogram law and the triangle law of vector addition, right?
Yes.
Okay, so any doubt, just do complete the test before time. Okay, bye everyone.
Bye, sir. Have a nice day.
Yeah.
Thank you, sir. Bye, sir.